Welcome to the OrientDB Getting Started training, working with graph data. As a quick review, there are three main actors in a graph data model. First, the vertex or node. Vertices are the primary storage mechanism for data, the same as a record. Relationships are defined by edges. This is a direct pointer between two vertices. The third is a property. This is a typed or unstructured element of data that can be part of either a vertex or an edge. So you could have a person vertex with a property first name, or a worksat edge with a property start date. The graph model allows for unparalleled flexibility. Data types can mix and create relationships in a completely free-form manner, while the overall system maintains incredible query and traversal performance. This is one of the things developers accustomed to relational databases experience, a feeling of complete freedom. Once you get familiar with using graph data, you'll find it hard to put your mind back in the relational database box. Let's look at some SQL extensions designed to help you work with graph data. You can always work with your data using the SQL insert and update commands covered in previous sections. These graph-focused commands do some extra checks and balances to ensure your database actions conform to certain requirements, such as the need for a vertex to belong to a class extending V. Here we have two commands for creating and deleting data: create vertex and delete vertex. Here are some examples. One creates a vertex with the person class and sets the first and last name. 2 creates a similar vertex but specifies it be stored in the Italy cluster. 3 defines a specific vertex with ID 24865. 4 deletes all automobile vertices where the current model property is false. 5 deletes all person vertices that has in edges with the class of membership expired. Edges also have corresponding commands for creation and deletion. Create edge and delete edge. The create edge command allows you to define two endpoint vertices with the to and from operators, as well as set properties. The first example here creates a lightweight edge from 10.3 to 11.4. It will belong to the default E class. Lightweight edges are edges that have no properties. Internally, they are stored more similar to links and don't have a document record in the database. 2 creates a lightweight edge of type worksat between the two vertices. 3 creates an edge and stores it in the Teamsters cluster. 4 creates edges from each person under 18 years of age to an R-rated movie with ID 14.5. 5 creates an edge between two nodes with a property value. 6 deletes all owns edges where the date property is less than November 2011. 7 deletes all owns edges with the date less than November 2011 and has an incoming edge with the property bought for with a value less than 350. 8 deletes all edges between two vertices that falls within a date range using the property embedded in the edge. And number 9 deletes all edges between two nodes with a class of comment and a status of spam. Traversals are where things get interesting. You can use traversals for flexible graph queries. They're suitable when the depth is unknown or gray. You can choose various strategies for traversal, and to be honest with you, they probably require a course of their own. Here are some concrete examples. Again, please understand this is a very broad topic with a multitude of options. Traversals are where graph databases move beyond the realm of what can be reasonably accomplished with a relational database. Here are some basic examples. 1 finds all vertices using the base vertex 10, 1, 2, 3, 4. 2 finds every vertex attached to 14,350 to a maximum depth of 2. 3 finds any person who has a vertex within 3 levels of depth with the property first name equal to Carl. Number 4 is an example where you probably don't want to use a traversal because we know the depth target is 2 ahead of time. Here we use a select and then chain out functions, which will result in a better query speed than a traversal with depth of 2. 5 returns the vertices that were traversed in order of traversal. 6 finds all friends of 10, 1, 2, 3, 4 to a depth of 3 using the breadth first traversal strategy. 7 returns the friends of 10, 1, 2, 3, 4 between the depths of 1 and 3. Finally, 8 traverses through all transactions attached to 1, 1, including buyers and sellers, up to 3 levels in depth that also has a buyer or seller rating greater than 6. Graph functions enhance the SQL functionality of OrientDB. They help you utilize the full benefits of a graph database. They mix nicely into the existing SQL API, and they have tremendous power. Let's take a look. 1 selects all cars that are model type 14300 and returns the colors. 2 selects all vertices connected through friend or brother edges in either direction to the person vertices with the last name equal to Davis. 3 selects all outgoing vertices where the bot edge has a purchase price property greater than 10,000. 4 selects all POI vertices with a distance of less than 30 from the hard-coded coordinates. 5 returns the series of steps that make up the shortest path between records 1330 and 27600. 6 uses the well-regarded Dijkstra algorithm to find the least weighted path between each vertex in V and 1330. 7 finds cars of model type 1212 that have sellers with good ratings from other car buyers. The graph functionality may be new concepts to you as a developer. Our main recommendation is to experiment with our example databases. The Grateful Dead Concerts database included with each OrientDB installation is a basic start, and the cloud-hosted Vehicle History Graph demo is a more complicated example. Both have data loaded to get you started. Here's OrientDB Studio running in a default installation. You can see we have the Grateful Dead concerts, and I can go ahead and log into that database using the default admin. And in here, you can look at the schema. It's a very basic schema with an edge and a vertice, and all of the data is stored in that level. We can go to Graph, select from V, and you'll see that they're all created in the V category. But there's a lot of relationships here that you can experiment with. I'll log out, and we can go to this download icon where it's import a public database. We'll put in our root credentials and choose download vehicle history graph. I'll use the same admin credentials, and we're into our vehicle history graph. If we go to the graph view and go select from make, you can see we have a lot of different data types that we can work with and different relationships that we can traverse through. There's also a model class. And you can learn a lot of good lessons with this database. The schema also has some interesting elements to it and a little more complexity than the Grateful Dead concerts.